All right, we are back. It's good to have you guys with me again. We're going to review this just for a second before we go on to 10.3. I hope you guys did all right on 10.2. This lesson is going to be dealing with chords. Remember, a chord touches the circle twice. But we're going to review this just for a minute, and because we'll be doing some problems that deal with this a little bit. It says find the value of x that C, given that C is the center of the circle and that the circle has a diameter of 12. So all these circles have a 12 as a diameter. So that is 12. So this would be 6. And this would be 6 if the whole entire diameter is 12, because that's a radius and that's half of it. And so then this would be 6. So because those are 6 and 6, we've got a right isosceles. So that means this is a 45, 45, 90. There's a couple ways you can do it. You can either do Pythagorean's theorem and you'll get a decimal answer, or you can remember that this is a 45, 45, 90. And the blueprint to it would be then this side is whatever this side is, square roots of 2. So this side is 6 radical 2, and that would be that. Or you can say 6 squared plus 6 squared equals x squared, and that would be 36 plus 36, and then square root 72, which comes out to be 8.49. So x equals 8.49, and I went fast. Remember, it has the plus or minus to it, but we only keep the positive. And then 6 radical 2 is the same exact answer. So either one of those would get it right for you. Okay. Well, here's a unique thing about this concept of being, this is exactly equal as far as, so 12 is our diameter, so this would still be 6 and this would be 6. Okay, well then this gets cut in half when this line comes to here. So what we can do is a couple different ways to figure out exactly how long this is. We've got the option of, if that's the diameter going there, then that's, or not diameter, that's the radius, that's 6. So if that's half, this would be 3. So then there's our 90 right there. Here's our hypotenuse. So this part would be like an A or a B as far as Pythagorean's theorem goes. And so then we will just go x squared plus 3 squared equals 6 squared. 6 is our hypotenuse. And so then we would go 36 minus 9. It's 27. And x squared would equal 27. And we'll move this down a little bit so you can see it. And then radical 27. So the radical of 27 is 5.2. So x equals plus or minus 5.2. That's what I told you it would be over here, but we get rid of the plus or minus and just x equals 5.2. Or the exact answer would be radical 27. X equals that or that. Either one of those would be correct. Okay, now on this one, over here, you've got to remember what kind of a triangle we have right here. There's total distance here and total distance here, meaning that this is a median, and a median hits the center of a triangle on that coming down from the vertex. Well, that makes this and this congruent. That makes this and this congruent. This is an isosceles triangle. Therefore, the two chords would be congruent on this picture. So then we would just say x plus 8 equals 2x minus 3, and we'll solve for it. I'm going to minus the 2x, minus the 2x, cancel, cancel. Negative 1x plus 8 equals negative 3, negative 8, negative 8. Negative 1x equals negative 11. Divide by a negative 1. And x equals 11 on that one. Okay, so that'll help you kind of understand a little bit about chords and these things as far as a chord. But remember, those we're using some of our knowledge of circles with Pythagorean's theorem, with chords, with diameters, with radiuses. You've got to be able to kind of put it all together and pick things out. When you're looking at triangles inside of circles, just remember, any line from the center to the edge is a radius. Any line going through the center from side to side, hitting the edges, is a diameter. That's double the radius. And then any pieces that are just touching the edges, not going through the center, is a chord. But we're going to discuss chords quite a bit today. Okay, lesson 10.3 with chords. All right, congruent corresponding chords theorem. The theorem says this: if I have two arcs, so this is a minor arc, if I have two arcs that are congruent, they're showing you the two marks. So I'll do it in blue right here. They're showing you that. If that arc matches this arc, then the two chords would be congruent. And that's what they're trying to show you. So if they gave you numbers, if this was 80 and this was 80 as far as the chord went, then that AB and side CD would be congruent. Now, they're not necessarily 80, they're not 80, but they would be the exact same length. Does that make sense? Okay, the next one is this: perpendicular chord bisectors theorem. It says this, in a diameter, it says if a diameter in a circle is perpendicular, so here's the diameter, and it's perpendicular to the chord. They're showing you that with the little red box. So if the diameter is perpendicular to the chord, then it bisects the chord. So in other words, then it does this to the chord. It does that and that, meaning HD will be congruent to HF. So as soon as you see a picture that looks like this, going through, and then we have this, and you get anything like that right there, as soon as they show you that, then you personally can mark that and that. Does that make sense? That's what they're trying to show you with that, okay? Keep that in mind. Whereas the converse to it is this: if a diameter, or if a diameter hits a chord and cuts it in half, so if a diameter hits a chord and cuts it in half, they're showing you it cut it in half, then you personally know that it's 90. And it's 90 degrees from that chord. So here's what they're showing you. I'm trying to show you this. Showing you a line going through, and it's doing this. Now, as soon as they show you this, as soon as they show you that, then you know this took place. That's what they're trying to show you on the converse. Okay, I'm going to go through it one more time real quick. Okay, what they did up here on this one is they showed you this. They said if I have a 90, so if I have a 90 with a diameter and a chord, if I have a 90 with a diameter and a chord, then this takes place. The chord is cut in half. Okay? I hope that makes sense. The converse to that is this one. So let's say I have a circle. I've got a diameter that goes through it. Doesn't matter where the diameter is. And I've got a chord. And they have the chord cut in half. If the chord is cut in half, the chord's already cut in half by the diameter, okay, then we know we have a 90. Does that make sense? I hope so. That's what they're trying to teach you on that one, okay? All right, well, let's take that into account. Well, let's see what we've got. Well, we've got, in this diagram, we've got circle P is congruent to circle Q, meaning they have the same radius. As soon as two circles have the exact same radius, then they are congruent. Well, they're telling us then that FG is then congruent to JK, and they're telling us that this arc measure is 80. Well, if that's 80, and they're asking us to go find the measure of arc FG, well, then this one would be 80. So we would say 80. That's what they were trying to show you on that first little theorem, okay? If two circles are congruent and they have chords that are congruent, then their arcs are congruent, okay? All right, here's the next one. All right, well, let's see what we've got. Well, what we have right here is we have a diameter hitting a chord. We have a diameter hitting a chord. That tells me that my chord got cut in half. That's what our theorem said just a second ago. Well, with that being true, they want us to find h to k. Well, h to k is the total distance of the chord. And if part of it from n to k is 7, then this would be 7. And 7 plus 7 would be 14. Our answer for that one. Then it wants us to find the measure of arc h to k. Well, if this is congruent to this, then it means this arc is congruent to that arc. So we would have to find x by setting those two pieces, those two arcs equal to each other. So then we would say 11x equals 70 plus x. We would subtract a 1x, subtract a 1x, we get 10x equals 70. We'll divide by 10, and x equals 7. Now, that's not what they asked for. We just found x. Now we can plug it back in and go get what we need. So, 11 times x is, or 7 times 11 is going to be 77. And then this would be 7 plus 7, which would be 77. And so 77 times 2, we get 154. By the way, just a reminder, 154 would be a minor arc. An arc that is minor, okay? And that's how you would set up and solve for that one, all right? All right, well then on this problem, they're gonna ask us how to find the center. Or how would we find an equal distance perfectly from each one of these bushes? Well, the best way to do this, they've arranged their garden and they want to be able to put the sprinkler exactly in the center between these two things. Now, I'm going to do it. I'm just going to explain it to you. We would actually need a measurement and some items. If you remember when we did constructions, that's what this would be kind of mostly like. What we would need to do is have a compass and a ruler and so forth. But I'm going to walk you through it and talk you through it and help you understand how to find these things so we can be perpendicular. Okay, to do this between the bushes, we want to be able to find the point that's exactly the same distance around these bushes. Well, if you'll remember, that would be the same thing as being able to find the center of a circle that would hit all three bushes. We need a circle that would hit all three bushes, so we need a center that has a radius of exactly that same distance. Well, the only way to do that is to find two perpendicular lines. So I'm going to draw some lines that might help you. And we'll use dotted lines to help us out. And I'm going to try to use yellow and see if it'll work. Okay. So first thing I do is connect all the bushes. Once I've connected all the bushes, I'm going to try to do them as accurately as possible. Once I've connected all the bushes, going through the center of the bush, then what I need to be able to do is find the very center, okay? And what I'm going to do is I'm going to try to just count right now because I can count this way to find that center, and then I'll show you what I mean. But normally we would need a compass, and you would want to find exactly the middle of it. You guys remember how we did that with compasses. But we need to find a line perpendicular to that one, and we need to find a line perpendicular to this one. And I'll do that with red dotted lines as well, okay? But I told you that I think we can just count it on this one to help us out. So if this one's if we're calling this 0, 0, I'm going to call this 4. So halfway would be 2. I'm going to say we're right up here, and we're right in the very center. And And then we are going to draw perfectly perpendicular straight down through it. And that would give us that perpendicular line. Now what I want to do is do another perpendicular line, one more perpendicular line so that it goes through the middle of this. Now I can count my tick marks as far as those go. I think we are going to be about right here. I told you the best way to do it is with a compass and making sure that you have exactly perpendicular. And I'll show you the final result and how this works once we're done. I believe my point is roughly about right here. Now, we'll know this is true when we can take our compass and extend it out and be on each bush. Now this is going to be close. It's not going to be perfect, you guys, because I didn't draw them exactly just for the sake of time. But once we've got that, once we draw our circle, you can see that if I put my sprinkler right here, it would shoot and hit every bush just like they asked. Does that make sense? So we're using the concept of, look, this is a chord. This is a chord. The two yellow lines are chords, and our red lines would be diameters. And what we've got is perpendicular bisectors, okay? Perpendicular bisectors, because we've got 90s, and they're cutting those chords in half. So we're doing the concept of this right here. We're doing this concept right here, you guys. We're doing the concept of these two theorems right here. Does that make sense? I hope so, because now this picture would work out. That's how you would actually do it in real life, so that you would be able to have a sprinkler in the correct spot to be able to hit each bush, because now it's equally distanced. Its radius is exactly the exact same for all three bushes. Okay? Hope that helps you understand the concept of it just a little bit more. All right, well, let's go into this and see if we can't figure out exactly what they want us to figure out on these problems. Here's some examples. In this picture, we've got a circle D. Circle D has two chords that are exactly the same distance. We know that if that's true, that then arc AB should be the same as arc BC. Does that make sense? Well, they're saying that in this first problem, arc AB is 110. Find arc BC. Well, it should be 110. By the way, that's a minor arc again. In this problem, they're saying arc AC, so this one, I'll draw it in blue right here, AC is 150. So now they want us to go find the arc A to B. A to B would be over here. Well, let's think about that. We have the rest of 360, and then it's half of that. Does that make sense? So the rest of 360 would be the distance all the way around the outside over here, the rest of it. And then we would just cut it in half. So we'll take 360 and minus 150, which should be 210. And then we're going to take the 210 and cut it in half. So 210 cut in half. Now, does everybody understand why we're cutting it in half? Because 210 would be that distance there, and we just want half of it for A to B. So it would be 105. Okay, let's move down to this one. Okay, it says in exercise 3 and 4, find the indicated lengths or arc measures. The length they want us to find is C to E. Now I know it's a segment because there's no measurement above it, there's no lines, there's no nothing. So it's segment CE. So segment C to E is this distance here. Well, let's take a look at our picture. We know right now, we know on our picture that this is a diameter and this is a chord. It's got a 90 on it, so we know that this segment is congruent to that segment. If that's 5, this is 5, and then CE would be a total of 10. Okay, find the arc measure of arc CE. Arc from C to E, we have congruent arcs, or congruent segment as far as C to F and F to E. Therefore, D to E arc and C to D arc will be congruent, so we can set those equal to each other to find X. So now I can say 9X equals 80 minus X. I'm going to add that 1X, add the 1X, and I'm going to get 10X equals 80 divided by 10. X will equal 8. Now that's not what they wanted. They want the actual arc. So 8 times 9. 9 times 8 is 72. 72 doubled, because this will be 72. And we will get 72 times 2, and we get 144. So this arc is 144. Again, that is a minor arc. So the arc from here to here would be 144. Any questions on that, you guys? Okay. We're almost there. We're going to talk about the equal distance chords. So, in the same circle or in congruent circles. So if they were congruent circles or in the same circle, two chords are congruent. So the chord is AB and chord CD. Two chords will be congruent if and only if they are equally distanced away from the center. So here's the idea. If you see a 90 and you see a 90, and then you see that we have F to E is congruent to E to G, if those are congruent, then our chords will be congruent. So if F to E was 7, and this was 7, then we would know that AB and C to D would be the exact same length. And that's what they're trying to show you right there. Now, some of the concepts that you can get from that are, well, if they turn around and say CD equals 10, well, then we know AB equals 10. But that's only if that and that was congruent, okay? F to E and G to E, as long as they're congruent, okay? So we can do that a couple different ways. You can also do it this way. I mean, in the converse, if I know that that chord and that chord are congruent, and I know I've got 90s, well, then I am guaranteed that those two distances would be congruent. So you can work it forwards or backwards, okay? All right, let's see what we've got. All right, it says in the diagram, QR equals ST, and those both equal 16. So QR, so Q to R is 16, the entire thing. So then this would be 8 and 8. And then we have C to U and C to V. So we know that this is the 16 as well, which is 8 and 8. So we know that that total distance is 16. We know that total distance is 16. As soon as we know that those are both congruent, we have 90s, then we know that 2x better equal 5x minus 9. And they want us to find the radius. Now watch, finding x is not going to find us the radius, but it is going to be able to help us find out what x is. Once we have x, we can draw a radius. I'll show you what I mean by that, okay? So then I'm going to say 2x equals 5x minus 9. We're going to set those two equal to each other so we can find x. I'm going to minus the 5x minus the 5x. I'm going to get negative 3x equals negative 9. Divide by negative 3. And I get x equals 3. Okay, so now that x is 3, I can plug it back in to find that distance. Okay, so I'm going to redraw my picture for you over here and just show you what I've done. Okay, so what we've done is we have, I'm going to draw the whole chord. I'm going to draw the whole diameter. Okay, we went and found x is 3. So this is 2x. This distance right here is a total of 6. I got 6 because it is 3 times 2. then this total distance we already knew was 16. That makes this 8. Because we have a 90 right there. Well, I'm going to now draw in my radius. That's the line we want to go find. So here's my picture. 8, 6, and now here's my X. Well, X was already on the picture, so I'm not going to put X, you guys. I've told you that before. I'm just going to call it C because it's the hypotenuse. So now we're going to do Pythagorean's theorem and find the radius. Okay? So 6 squared plus 8 squared equals C squared. So 6 squared is 36 plus 64 equals C squared. 36 plus 64 is 100. And the square root of 100, C equals, move that down a little bit, square root. Remember, we get C equals plus or minus 10, but we do not use a negative distance. And our radius on this problem is 10. Now, if they had units or whatever, we would have put in the units, but that's how you do it. We're going to do this problem one more time, so it'll help you out, okay? All right, we're going to do one more like it. All right, so in this problem, and they've got all these lines on there, don't panic. Don't panic that they have all this stuff. Just kind of start putting stuff on the picture. So JK is 24. LM is 24. The moment we know that, then we know that these are equal distance because of the 90s. Because those are equal distance, now we can set them equal to each other to find X. So then I'm going to say 3X equals 7X minus 12. I'm going to minus the 7X, minus the 7X. Negative 4X equals negative 12. Divide by negative 4. X equals 3. So now that 3 can actually get put into either one of those spots. But watch, I think you understand now that this would now be just 12. Everybody with me? This piece, 3 times 3. 3 times 3 will just be 9. And then watch, there's my radius. That's the one I'm looking for. That's my question mark. Okay? So I'm going to redraw it over here so you see it a little bit better. Here's the picture. There's the 90, there's the 3, there's the 12, and there's my question mark, which is C again. Everybody see it? That's how you'll do it every time. So then we'll go 3 squared plus 12 squared equals C squared. Remember, the hypotenuse has always got to be on the opposite side of the A and B. We get 9 plus 144 equals C squared. And we get 9. It's 153. So C squared equals 153 square root. C equals plus or minus 12.4. So that's our distance and that's our radius. So then we'll say radius equals 12.4, give or take. The exact answer you would just put would be radical 153 if you wanted exact. Approximate, it's a 12.4. We know that's correct because it's longer than the 12. Okay? Well, good luck with that. I think you guys will be all right on that. You should be good to go. If you have any questions, you can always email me or give me a call. Get your homework done. Good luck. Shake and bake.